Hello students, welcome back to the video lecture series. Today we are going to wind off projection of planes by completing the drawing number 9. In drawing number 9 now you have 3 problems and all the 3 problems are based on simple position 4. So let me explain you what is simple position 4, then we will go and solve all the 3 problems today. And I want to remind you that the submission of drawing number 8 and 9, the last date is 31st of this month, 31st March. You need to submit both the drawings online. Okay, now let me explain you what is simple position 4, taking this as example. This is a square lamina. If you consider this to be a square lamina, this is simple position 4. If you remember in the last class, we discussed about simple position 3. Simple position 3 was this. The lamina was in VP and I made sure that the right side edge is taken perpendicular to HP. But now what I am going to do is, this is the position I am going to take. The lamina is still in VP, but I am taking a corner on the right side. So if it is a square lamina, this is a square lamina. So this is the position in VP. So this is the corner which I am interested in. So this is going to be your first step. So in this position, in the front view, you will be able to see the actual lamina in its actual size, and the top view appears to be a line, and the line appears to be on XY line. This is your first step. Okay. When you move to second step, you are going to rotate the surface about this right corner. So the lamina will be rotated about this right corner to the given inclination. This will be given to you in the problem. What is the inclination of the lamina with VP? Okay. So in this position, you will be projecting and getting what is the front view and what is the top view. The top view still remains to be a line even in the second step, but the front view will not be a regular square in this case. Okay. So this is about simple position 4. And once again repeat, this is going to be your first step, a corner on the right side. When you move to second step, you are going to rotate the surface about this corner. So only one corner will be there in VP, that's all. The lamina is inclined to VP at a given angle. Now coming back to those 4 questions, the first question is this: what is simple position 4? So this is simple position 4. We can say the surface is in VP and one of the corners is on the right side. That is how we take. Then the second question is when to adopt simple position 4. When you are given this position. What is this position? The lamina is resting with just a corner on VP and the surface is inclined to VP. So this should have been the condition given in the problem to you. Okay, so this will make you to adopt simple position 4 as this. This is simple position 4. Okay, a corner on the right side, the entire surface is in VP. The next question is how to start. How to start solving the problem? You are going to start by drawing the front view first. You are going to start by drawing the front view first. That is how you are going to start the problem. Then the last question is how to proceed. Like in the previous case, here also SP4, VPC and HPC. This is the order. In the first step, you are going to satisfy SP4, simple position 4, and then you will move to VPC in the second step, and then followed by HPC in the third step. This is how you are going to solve all these 3 problems. Okay. So I repeat once again. What is SP4? Surface of the lamina in VP with one of its corners, preferably the right side corner on the right side. Preferably the right side corner, the corner on the right side of the lamina is on the right side. Then the second question is when to adopt SP4. When this is the position given to you. Corner in VP, the surface is inclined to VP. When you find this condition in the problem, you are going to adopt SP4. Then how to start? Start by drawing the front view first. Then the flow of the problem is like this: SP4, VPC and HPC. Okay. So now I am going to demonstrate to you the problem number 2.3.10. This belongs to drawing number 9. So please watch carefully how I am going to solve this problem. So this is a pentagonal lamina. I want you to keep your question bank ready with you for your reference, because I am not reading out the entire problem. So the problem number is 2.3.10 of drawing number 9. So it's a pentagonal lamina. I am starting by drawing the XY line. This is your XY line. We are adopting simple first angle projection, VP and HP. So as I have already mentioned, we are going to start by drawing the front view first, and also you are going to take a corner on the right side. So it's a pentagon. So I am drawing a pentagon in the front view. This is the left side edge. With this as one of the edges, I will complete my pentagon. So this is the corner which I am interested in, this corner. Okay. Now let me start naming the corners starting from this corner only. So I will call this as A dash, B dash, C dash, D dash, E dash. Now the edge is 25 mm. So I will mark this edge. This is 25. So this is the first step, the front view of the first step. Now I will project this down onto XY line and draw the top view. As I mentioned already, the top view is going to be a line. This is the line. Now this is the position of the observer. So out of D and C, D is visible, C is invisible. Out of E and B, E is visible, B invisible, and then A. So this is how the top view appears, which is a line. Yes. Now this we call as SP4. You have drawn both the top and front views. As I mentioned already, the flow is to satisfy VPC in the second step, vertical plane condition. And what's the vertical plane condition? The surface is inclined at 30 degrees to VP. Not only that, with corner A in VP. So I am going to rotate the surface in this direction about the point A. So I start with the point A on XY line. Okay. Draw a line inclined at 30 degrees to XY line. So let us say this is the line which is inclined at 30 degrees to XY, and I am going to mark this plane on this line. So I start with A, and A to this BE, mark the point BE, and then measure this distance and mark the point CD. So C in brackets, D outside. So this is the surface. This should be made dark, and you need to find, this angle is given, it is given as 30 degrees. So this is how the top view appears in the second step. Now I need to project and get the front view. So I am projecting all the 5 points up, and also I will draw the locus of all the 5 points from the first step. Done. You have done that. Now the intersections will be, with the help of the intersections, I will be marking the points. This is point A, this is B, C, D and E. Now connect them using straight lines. This is in fact dash because this is front view. So this is how the front view appears in the second step when the surface is inclined at 30 degrees to VP. It's no more a regular pentagon. The only one edge which is in its true length is CD. It's the only edge that is in its true length. The remaining 4 edges are apparent in length. Done. Now comes the third condition, the third step, HPC, horizontal plane condition. Now what is HPC in this problem? The HPC is given with reference to this perpendicular bisector. This is the perpendicular bisector. The HPC is given with reference to this edge. Now, is this edge in its true length or apparent length is what you need to check. No, it is not in its true length. It is in its apparent length. Because this is the true length of the perpendicular bisector. I will show it by a thin line here. I will name this corner as some F dash. So A dash to F dash is the true length of that perpendicular bisector passing through the corner A. Okay. So if A dash F dash is its true length, in the second step you will have its apparent length. So I will call it as F1 dash here. This as F dash. A dash F1 dash is its true length. A dash F dash is its apparent length. Now, whether you are given the true angle or apparent angle is what we need to check. The statement given is this. The perpendicular bisector is inclined at 45 degrees to HP. So it is the true angle. You are given the true angle, but you have the edge in its apparent length. So it's a combination of apparent length and true angle. So I have already told you how to find the apparent angle. This is the procedure that we adopt. I repeat once again, you have a scenario where you are given the true angle of an edge, but the edge is in its apparent length. Under this scenario, what is to be done? This is what you need to find or you need to do. So I'll start by drawing the true angle first, which is 45 degrees. So this is 45 degree line. Because this is true angle, I am going to mark the true length of the perpendicular bisector on this. This is the true length. True length you get from the first step. So this is your A dash and this is F1 dash. This is the true length. Now from this I need to find the apparent angle. So what do? I draw the locus of the point F1. Then take A dash as center. A dash F dash. This is the apparent length of the perpendicular bisector. Take this as radius with the compass. A dash as center. Cut this. So this is your F dash. Now connect this. You are going to get the apparent angle. This is called alpha, because in the front view we call it as alpha. In the top view we call the apparent angle as beta. So the alpha you must get it as 55 degrees. I am writing it down here. So you can check this angle should come to 55 degrees. Done. So now this is the top view of the perpendicular bisector, which should coincide with this. Okay. Now you need to get the remaining 3 points. You have the remaining 4 points in fact. Okay. You have only A dash here. There are 4 points lying on this pentagon. So we need to get them now. Okay. Let us see how to get it. Now if you check this C dash D dash, it is exactly perpendicular to A dash F dash. So you already have the A dash F dash line. So draw a line perpendicular to that, so that you can mark the point C dash D dash on that. You can use a protractor to draw this line, marking 90 degrees. So this line is drawn perpendicular to A dash F dash, not A dash F1 dash. Please remember that. Done. The perpendicular is drawn. Now you can take these measurements. So because this is 25 mm, this is also 25, each of this will be 12.5 from F dash. So from F dash you can mark 12.5 and 12.5 on either side. So this is your D dash and this is C dash. Done. Now you have 3 points. A dash is there, C dash is there, D dash is there. You are required to get the points E dash and B dash. For that you can use your compass to get them. Okay. So take A as center, A dash E dash as radius. Draw an arc. Now take D dash as center, D dash E dash as radius, cut that. So wherever they intersect, you get E dash. Similarly on this side, okay, A dash, B dash is radius, A dash is center, you are going to get B dash somewhere here. Okay, now you need to connect the points. This is it. So this is how the front view appears in the third step. Okay, now with this as the front view, you need to project and get the top view. Okay, now A, let us start with A. This is the locus of A. X-value itself is the locus of A. So I project A up to the locus of A. So I can call this A. Now draw the locus of the points B and E. Project B and E down. This is B. This is E. Similarly, C and D. Draw the locus of the point C and D. Project the point C and D down. As soon as you project it, just name it. I have seen some students waiting till the last, till you complete all the projections. Don't do that. As soon as you draw the locus and draw the projections, just name them. That will help you a lot. Avoid the confusion. Okay, that's it. You are ready with all the 5 points. You can connect them by straight lines to get the final view. This is how the top view appears in the third step. So what you should understand here is, whatever is given in the problem, there is one HB condition and another VP condition. All the conditions are satisfied in the last step only. Okay, so to satisfy what is given in the problem, it has taken us 3 steps. You can't straight away draw this position. Okay, it has taken us 3 steps to arrive at what is asked for in the problem. Okay, first we are satisfying SP4, then you are satisfying VPC, and then finally you are satisfying HPC. Okay, so that's it for this problem. Now I'll take a small break and then come back with the problem number 2.3.11. That's it. See you back.